Good morning, madam. I am Monica. I am from first year BTech CSCD section. Now my topic is the volume of the greatest rectangular parallelepiped that can be inscribed in the ellipsoid x square by a square plus y square by b square plus z square by c square equals to 1. Moving on to next slide. Find the volume of the greatest rectangular parallelepiped that can be inscribed in an ellipsoid x square by a square plus y square by b square plus z square by c square equals to 1. This question is also asked as find the volume of the ellipsoid x square by a square plus y square by b square plus z square by c square equals to 1. Solution. The solid figure x square by a square plus y square by b square plus z square by c square equals to 1 is cut into 8 equal pieces by the 3 coordinate planes. Hence, the volume of the solid is equals to 8 times the volume of the solid bounded by x equals to 0, y equals to 0, z equals to 0 and the surface x square by a square plus y square by b square plus z square by c square equals to 1. For a fixed point x, y on the xy plane, z varies from z equals to 0 to z equals to c into square root of 1 minus x square by a square minus y square by b square. Consider the quadrant of the ellipse in the first quadrant of the xy plane. For a fixed x, y varies from 0 to b into square root of 1 minus x square by a square. Then x varies from 0 to a. Hence the required value 8 into integral x equals to 0 to a integral y equals to 0 to b into square root of 1 minus x square by a square integral z equals to 0 to c into square root of 1 minus x square by a square minus y square by b square dz dy dx. Now we have to integrate with respect to z by keeping xy as constant. Integral z equals to 0 to c into square root of 1 minus x square by a square minus y square by b square into dz. By integrating dz we get z integral 8 into integral x equals to 0 into a y equals to 0 into b into square root of 1 minus x square by a square z into limits 0 to c into square root of 1 minus x square by a square minus y square by b square dy into dx. 8 into x equals to limits integral x equals to 0 to a integral y equals to 0 to b into square root of 1 minus x square by a square c into square root of 1 minus x square by a square minus y square by dy into y square by b square into dy into dx. Write 1 minus x square by a square equals to b square p square by b square equals to b square into 1 minus x square by a square. P equals to b into square root of 1 minus x square by a square. Now required volume equals to 8 into integral x equals to 0 to a integral y equals to 0 to b p c into square root of p square by b square minus y square by b square into dy into dx. Then we can write as 8 into integral x equals to 0 to a into integral y equals to 0 to p c by b into square root of p square minus y square dy into dx. 8 c by b it is constant by keeping one side. Integral x equals to 0 to a integral y equals to 0 to p square root of p square minus y square dy. With respect to y we keeping x as constant. Then integral y equals to 0 to p square root of p square minus y square into dy. Put y equals to p sin theta, then dy equals to p cos theta into d theta. If y equals to 0, then theta equals to 0. And if y equals to p, theta equals to pi by 2. Then p square into integral theta equals to 0 to pi by 2 cos square theta into d theta. We know the formula. If n is even, integral equals to n minus 1 by n into n minus 3 by n minus 2 into and so on into pi by 2 when n is even. Hence p square into integral theta equals to 0 to pi by 2 cos square theta into d theta equals to p square into pi by 4. Pi by 4 into b square into 1 minus x square by a square. Equation 3. Using 3 and 2, the required volume is 8c by p into pi by 4 b square integral x equals to 0 to a 1 minus x square by a square into dx 2 pi by bc into x minus x cube by 3a square. Limits from 0 to a. 2 pi bc a minus a cube by 3a square minus 0. Then we get 2 pi bc into a minus a by 3. A minus a by 3 is nothing but 2a by 3. We get the answer 4 pi by 3 abc cubic units. Thank you, madam.